All right, here we are in part 2 of 3 in our groundwater video lecture. And so I defined groundwater in my first video as all water that's stored within rock and sediment underground. But we didn't talk about the primary source for our groundwater. And this is a pretty obvious thing, but the primary source of groundwater is precipitation. So snow and rain fall from the sky, and that water percolates down through the soil and then through pores between sediment and rock below. And it's stored there underground in reservoirs that we call aquifers. Obviously, for agua, there's the root of that word. So you can think of the ground as like a sponge, analogous to a sponge in the kitchen sink. So it has a capacity to store this water. And there are really multiple pieces and parts to this puzzle, in that as the water percolates down through soil and then rock and sediment, it starts to fill in empty pore space with water. And this region where it's filling in the pores is called the zone of saturation. Just like I said, saturation of a sponge in the kitchen sink, for example. When that precipitation ebbs, meaning it slows down, you have less of that recharge, and consequently you have less of an area that's filled by water between pores. So this area where there is air and sometimes water is called the unsaturated zone, and this is directly above the zone of saturation. So I'm going to show you guys what that looks like here in cross section, because really it's hard to understand this if you don't see a picture of it. So imagine it rains really hard like it did over the weekend, right? And so all this rain falls to the ground and it seeps down through the soil at the surface and then down through sediment and rock beneath it, and it starts to fill up this zone of saturation. So I don't know if you guys can see this, but this little block here is the same as this guy blown up. So we have 2 areas here. We have the blue area and then the beige area. And what you're looking at is the zone of saturation, where sediment is going to fill with water. So the water's occupying the space between those sediment grains. And this space is called pore space. And I have a separate video where I do a little lab demo with pore space. So anyway, that space is filled with water. And then eventually, if the rain stops, there's no longer a source. And so the area up above the zone of saturation is what we call the unsaturated zone. So rather than water occupying the space between sediment, this is air and sometimes some trapped particles of water. And the important thing here is that you notice kind of the interface between those 2 layers. It's right here. And it's right here on this cross section. So this is what we define as the water table. And the water table is very important in that the water table can fluctuate seasonally or yearly. It can fluctuate by region. And this becomes important because a lot of areas around the United States rely on well water for domestic and agricultural and industrial use. And so a well is like a borehole that's drilled down into soil and rock, and it's used kind of like a straw to extract the freshwater resources from this aquifer or the zone of saturation. And so the depth to the water table can vary, and obviously if the source is precipitation, it's going to vary depending on seasons, and it's going to vary depending on climate. If there's a drought, like in California for the past 10 years, That's going to affect it. If there is an inundation of rainfall like we've had in central Ohio, that's going to affect it. So it's kind of a bit of a tricky thing to understand because the water table can change its level beneath the surface. And the surface is really kind of a snapshot of what's happening underground. So surface topography actually mimics what's happening below, and can kind of give us a sense for where groundwater is and where it's going to flow. Because just like gradient on the surface, there is a gradient underground that describes where groundwater is. And so the only thing that makes it, well, not the only thing, one of the variables that makes it real tricky is that when we're studying the water table, we're really not studying it directly. We can only see evidence of what's happening on the surface in the form of surface water, like rivers and wetlands and lakes. Otherwise, we have to use other tools in order to understand what's happening below at depth. Makes sense, right? So geologists, actually hydrologists, it's a field, and I'm going to tell you right now, this is going to be a money-making field in the future, because as population increases and freshwater resources decrease, hydrology is going to be like the oil industry was in the 1970s. So hydrologists will monitor the water table, and what they look for, it's kind of hard to see here, but these are wells across the state of Missouri, and what hydrologists are studying there is the relationship between the water table depth over time and periods of heavy rainfall and then drought, heavy rainfall and drought. And we call those periods that kind of alternate here on this graph times of recharge and then discharge. And so you can kind of see the seasonal decline here from like an abundance of fresh water and a higher water table to, and that would be like early summer, spring. You can see where that drops over the summer months and into the early fall, because typically summer months in Missouri are dry. And so as we use the water and pump it up and out of these wells, we're extracting it, but the normal recharge through precipitation is not replenishing the water table. So the water table is going to drop over time. And then typically in Missouri, they get rain in kind of the late fall into the winter that recharges the water table, and we go back to the start of another cycle. So dry season, water table drops. Wet season, water table rises back up towards the surface. And this is really important to understand, because if we don't understand the water table, man, it becomes real tricky in being able to kind of mitigate water or freshwater use. So let's kind of look at the water table from a different perspective. And so here you can see the water table. I'll just highlight. I'm going to use a different color. Let's do purple so you guys can see it. So here's the water table. Say this is in Missouri as well. And you can see where the water table surfaces in this channel right here. That's a river, right? And that river is fed by water under the ground. Similar to the Olentangy River, which runs down through Ohio State University campus. And so if we have enough precipitation, that river is going to maintain the same depth over time. But what happens is when the amount of precipitation is exceeded by lack of precipitation, the water table starts to drop. And here you can see that as the water table drops, there's kind of a change in gradient underground. So the water table is dropping, which is pulling water out of the river. So again, if this were like the Olentangy River near Ohio State, during kind of a dry season or a drought, the water table drops and that river starts to run much slower and lower. Eventually, over time, if this continues and there is not recharge in the form of precipitation, that river can dry out. And that obviously would be concerning to all of us. So in the next video, what we're going to talk about is more of this recharge and discharge and what's happening underground. Actually, you know what, I'll continue to do that here. And then our last video, we'll talk about groundwater resources. So obviously the recharge would be precipitation, and the discharge would be either based on topography or extraction of groundwater resources from wells. And all of these things, recharge and discharge, affect the way that groundwater flows in response to gravity and pressure. And so groundwater actually moves, and it's going to mimic, like I said, the surface topography, in that what happens underground is kind of similar. It's going to involve a lot of variables. So there's kind of topography underground. There's also sediment porosity and permeability, which determine how fast and how far water can flow. And so these become important variables to understand, especially in areas where we drill wells and we pump groundwater up and out. Because if we don't understand the gradient underground, how are we going to understand where to access that aquifer? In other words, where to drill wells and how to get the water up and out. So wells are just a hole that's drilled into the soil and then the bedrock beneath it. And those wells are used to extract groundwater resources from the ground. And what happens is through that extraction, we see a lowering of the water table, right? So the water table, again, is just the boundary between the zone of saturation and the unsaturated zone above it. We drill wells, and by we, I mean hydrologists will drill wells into that zone of saturation. And what they'll do is they'll pump water up and out of those wells. So you can think of it kind of like a straw, you know, in a can of soda or whatever. And so as you suck the soda up the straw, it's going to lower the water table beneath it, and it creates something we call a cone of depression. So there's almost like a suction, a force that causes the water table to drop closest to the well that's pumping the water up and out. So this would be like an irrigation sprinkler, right, on a farm. So this becomes important because a lowering of the water table can affect not only the well that's withdrawing the water, but any wells that are in and around the area. Because if you're pumping a lot of water up and out, lowering the water table within an area, you can cause some of these wells closest to your cone of depression to run dry. And obviously that's a big concern. I'm going to go ahead and stop here, and we'll talk about the importance of conservation in the third video. All right, signing off for now.